Warning: tube amplifiers have lethal voltages inside them. Please do not attempt to build, test, or repair these without understanding and following all safety protocols. Hey y'all! Well, we're back working on the 6C33C amplifier. This is a very unique tube. Operates at really low voltage for a vacuum tube, about 200 volts. A lot of amps, like 200 milliamps, and it gets to the wattage in a very different way than most vacuum tubes do. It also uses a really low impedance output transformer. It's got 600 ohms on the primary winding, and supposedly that makes it a lot easier to wind a transformer that sounds good. And in this case, we've got an ED core that we've painted black. We got Hammond power transformer. Went with mono blocks because there's so much current. Getting a power transformer that would feed both tubes was going to be ridiculous. And I know many times monoblocks are built to separate the power supplies for a different reason, but in this case we're just doing it solely because these things draw so much current that the cost of buying a single transformer was going to be just off the chain. We're also going to use a plate choke, which you can see right here. This is another Hammond unit. I'll put that in the description, and you'll actually see it on the schematic. Here's the power supply, and then this is the amplifier itself. And like all of these projects, I have no idea what this thing's going to sound like. So if you're building it along with me, you're taking the same risks I am that this is even going to work. And most of this schematic came from a known working type amp. But again, I have no idea how well it works, what it sounds like. I've still got another issue with, I'm using a little different tube because the D3A has become so ridiculously expensive. We're going to be trying a Russian variant, which is then known to be super microphonic, which may be an issue we run into. So, don't know. May have to scale this thing back and use like a 6EJ7 or some other, variant of that style, made in USA tube, and might lower the input sensitivity where we need a pretty hot preamp to drive this thing. So, yeah, I don't know where this is going. I am building these as power amplifiers with no volume control. And in this video, we're going to work on the power supply and mounting the tube socket and the heater for the output tube. And as you can see, the tube socket's mounted. I'm shooting this segment after that I've done the work on the amp. So, yeah, you'll get to see how I mount this. You can see it's external. We got an air gap around the bottom of it, trying to make sure that it's not easy for somebody to stick their finger in under the socket. You'd have to really work at it to get your finger under there, so I feel that that's safe. We're also going to have the cathode resistor external because, especially with this tube running at cathode biased, it's going to get super hot, and I wanted to keep it from outside of the chassis so we don't trap all that heat inside. We got this power resistor. We're going to add this little screen here in the back of the amp right here. And I did order what I thought was going to be all the parts I needed for this, but it turns out once I started putting the tag strips in and laying everything out using the existing bolt holes for this iron, that those capacitors really weren't ideal. And so we'll get into that when I show you how I'm laying this out and how I decided to lay everything out. So let's get busy building the power supply. Okay, so I'm here starting to wire up the power supply in this 6C33C amp. And we're going to be using solid state rectification. We've got our diodes here. The high voltage from the transformer did it like this. We got really short wires that go straight to this tag strip, which is nice. Goes straight to these diodes. Had to bend these over the tabs to have enough length so we didn't have to like add extensions onto these wires, which really wouldn't have done any good. I didn't see any point in doing that. And so we've also got the center taps from the heater and the high voltage coming over here to our star ground point, which is right here. And we ground the paint or the powder coating off the chassis to bolt this down nice and solid. Lately I've been trying to not use this mounting point for the ground on the remote ground points. I've done it in amps in the past, didn't have any problem with it, but you know, theoretically it's not a good idea, and I'm just trying to get away from that practice. So we ran a ground wire from here to here, and so now I'm trying to figure out what to do with the rest of the power supply. And I've got some of these radial lead caps that are the right size, but I started looking at, you know, if I put them like this, they're going to be just kind of floating in the air. And what am I going to do with the second one? Am I going to put it like over here or something weird? It just wasn't going to, you know, I know you don't see the inside of the amp, but I like to have things laid out really neat on the inside of my amps. And yeah, it just wasn't working for me. And I could have run it up here, like put one kind of like this. Might even have been able to get it to like, might have been able to even get it to like sit down in there like this. And then have the other one going like this. But I like keeping the AC power supply as compact as possible. And then I found one of these in my stash, and that's going to work great. I have a pair of axial lead 220 UF 350 volt caps. So I can put one there, and then I can put the second one like right there, right next to it, and that'll be nice and neat. So then we can run the wire to the choke from here to here, and then run the wires from our dropping resistor. We're going to be using this 25 watt 50 ohm resistor as the RC filtering. We're going to have a LC and an RC, which is a choke capacitor, and then a resistor capacitor is the second stage. And so I can just run it across from this lead to that lead, which will keep the wires nice and short. And then this will be our final B+. Then I can tie these two grounds, or these two tag strips together to have grounds for the ends of these capacitors that are going to sit in there like that. So I thought that was a really neat solution. Now the choke we're going to be using is this 4 Henry 225 milliamp guy. And again, this amp or this tube uses a ton of current at low voltage. So it's going to take a big choke like this to be able to deal with the current. So this guy, I've decided I'm going to set it over here on this side rail and probably put it with the wires down like that. And then they should be able to, might have to extend these wires. If I do, it's no big deal. We can splice a wire in with some heat shrink tubing. But I'm going to mount this guy over here like this, over here in this corner, kind of, bolt it onto this side. And then I'm going to put this resistor here on this back wall here away from these capacitors. And then I'm going to put on one of my little screen things right there, punch a hole and put that on the top of the chassis for ventilation. So we'll have this resistor sitting back here, and then have the screen there, and then drill some holes in the bottom of the chassis along this edge to dissipate the heat off this resistor up through the top of the chassis. The last thing I'm going to have to deal with is these are the speaker output leads, and Originally I was going to run them out the side of the amp, but that's just kind of weird. And there's really not a whole lot of benefit to that. So I think I'm just going to run them like this and run them out of the back of the chassis like would be normal. We are going to have the input jack up on the front on the top. I've decided I'm going to do that, but we'll do a normal speaker output and just put the 2 speaker jacks here on the back of the amp. So, need to punch this hole, need to figure out, mount the speaker things here. I am going to have to order some of these caps. I've only got one of them. And it looks like Tubes and More have these in stock. So, going to order a set of these. And for the first capacitor, I've decided to reduce it down to a 33 UF, which will make the transformer happier. And it's just going to go across here from what will be the DC off the rectifier or the diodes to ground. So it can just, that little guy can just kind of sit back there. And then I'm going to tie these 2 tag strips together to have our rectified DC going into our filter network. And then at the end of the day, this will be the B plus that can then, the output transformer, come back there and connect to that really easily. And then run the B plus up here to the front end tube. So that's kind of got the power supply sorted out. So I'm going to, like I said, punch a hole here for this screen and then install the speaker jacks probably right here in the center, like right here in the back, right next to the power connector. Then this black wire comes up and connects to this lower pin on the IEC, which is, let's show you, this is the non-fused one. So that's the one that goes straight to the transformer. This one goes to the switch, and this one goes to the chassis to ground. So going to get that bolted in, run this over to our little terminal here that bolts onto the chassis. That'll be our safety ground. And then this will come up to the IEC socket. And then this one is going to run up here. And I decided to just put one of the little push button switches with the indicator light here on the front of the chassis. And run the AC switched along this ledge here. And done that in a lot of my amps. Really like having a on-off switch on the front of the amp and not in the back. But hey, if you want to put it on the back, some people even used a IC socket with a switch and a fuse on it just to eliminate having to have a switch. But I like having an indicator light on the front, and those little on-off push button switches look really nice. So we're going to do that little deal up here. So I'm going to figure out where I'm going to punch the hole for the switch, get it mounted, and get it all wired up. And then I may actually wait to mount it until I've got this tube socket wired up so that we don't have any interference between, while I'm trying to work around this tube socket. And then I'll have to start figuring out where I'm going to run the rest of the wiring. I have been thinking about running the heaters kind of like this, and either having a tag strip here or here. I haven't decided yet. I got to kind of look at where the wiring for the front end tube's all going to be. And I haven't drilled the little holes yet for the tube ring for it, because I need to figure out where I'm going to put the tag strips around this tube. And then these are the plate choke for the front end tube. So one of these wires will come along and back here to the B plus back here in the back. And yeah, that's right, the plate choke doesn't go straight to the B plus. It needs a dropping resistor and a capacitor before it. So we may do something along, put a little tag strip along one of these bolts that'll have, they'll have the B plus come up here to that, and then have a dropping resistor with a capacitor to ground, and do it like that. It'll also be a good remote tag point for the tubes that I could then run back here or all the way back here if I want to the start ground point. So yeah, we're just figuring this stuff out. And I know some of you folks are like, hey, why haven't you shown us doing this amp? It's because I've spent several hours just kind of looking at this, trying to figure out how I want to do this. And I know for some people it's like maybe a lot easier, but for me it takes a while to kind of visualize where all the components need to go on the tag strips, and which kind of tag strips that I need and all that sort of stuff. And so yeah, I think this is going to turn out really neat. So like I said, let me get these holes drilled, let me get the speaker jacks mounted, and get some of these capacitors ordered. And yeah, that'll take me a little while to get to that point, and maybe for the next video we can then start figuring out what wiring up the front end tube looks like, where we're going to run the heaters, and get the socket mounted for the power tube. And I have decided to space it above the chassis with these little aluminum spacers so that it can radiate the heat off the socket in open air. I've heard they get really hot. And then I'm going to leave this big hole in the bottom for ventilation so the air can go through and around the tube socket and around the tube. So these, the plate leads and stuff will be kind of going through here and then connecting to the tube socket terminals. And I want to make sure that there's not enough clearance here for somebody to stick their finger in there and touch anything electrical, so it'll be safe. So I did go ahead and get the tube socket mounted. We have these little Allen bolts with some washers on both sides of this socket, and this is the good made in Russia socket that really grips the pins tight. The little China ones are junk. And then, man, this thing pretty freaking heavy. And then you can see I put some spacers so that the air can come out and the wires will clear the top of the chassis. And they're going to come through like this. This is the plate that goes over to the output transformer. Got the two heater wires using some 16 gauge wire over here to this tag strip. And then these are the heater wires you see here that come back here to the transformer. And then later we can pull the heater for the front end tube off of this point here. Have to figure out how I'm going to route that when I wire up the front end tube. And this green wire is the grid and this black wire is the cathode. So you can see we got this big hole here. This is the biggest hole punch that I've got. And we punch this out to let the air come from the inside of the chassis. We'll have some holes drilled underneath the tube here so the air can go through and come across and keep this socket cool. Because I've read that's an issue with these tubes. They get the socket super hot. So that's kind of it for right now. I gotta work on how I'm gonna wire up the front end tube and wait for the capacitors for the power supply to come next week. And gonna, like I said, we gotta punch this hole back here for the screen, and then mount my speaker jacks, mount the choke, mount the resistor. I can get some of that wired up and get the switch wired up. So we'll work on that for the next video, and this is a good place to wrap this one up. Well, as you can see, we're zipping right along, and I got the socket all mounted up, got it wired up, got the idea of where all the rest of the layout's going to be. I am going to go ahead and get the speaker terminals mounted, get my little screen. This little guy is going to go back here, going to get it mounted, get all the rest of the holes drilled, get the choke mounted in preparation for the capacitors that are coming later this week. I could have just kind of cheaped out and used the ones I had, but I could use those on another project. And I know some of you folks get upset when I leave something off a bomb and they're like, oh my God, I had to make a second order and I had to pay another $7 shipping on my $1,200 amplifier. Yeah, I end up sometimes making 2 or 3 orders for the same amp because I forget things or order something wrong or I change my mind in the middle of it. So that's just part of building these things. And I know some people, that's kind of their pet peeve. It's like, I want to order everything all at once from one place. And yeah, can't help that if you've got that issue. So anyway, here's the tube mounted in the socket. Like I said earlier, this is elevated up off the chassis to help with cooling of the socket and the tube. These things get super hot. We're not running both heaters, so maybe it won't be quite as bad. And the way I'm wiring this up or designing these, we're going to have, this will be the right hand, or from your direction, the left hand. And then the other will be the mirror of this with the tube sitting on the outside. I'm going to power the heaters on the outside so that as the tubes age, you can swap them. And we've also got this cathode resistor mounted on the top of the amp to help keep the heat out of the inside of the chassis. Not sure yet if these Russian driver tubes that I'm going to try to use are going to work out. The D3A tubes have gotten just stupid expensive. I mean, to buy a pair of those for this amp, probably going to be $400 unless I really just sit around and wait. They've gotten just, people use them to drive 300B tubes, and they don't make them anymore. Nobody makes a, tube of that style. These Russian ones are real close, and if they're too microphonic, which I've heard that can be a problem with them, and I can't get a good pair of them. I got about 10 of them to choose from. I bought a box of them. If none of them will work, then we'll punt and try to use some variant of a 6EJ7. There's some options out there that maybe aren't quite as hot, but might get enough drive. Might have to use a little hotter preamp with it, but that's okay. I was planning on using some version of a color preamp to drive these things anyway, or maybe just my wood one I've got. And we're going to put the RCA jacks to the front, so it'll be kind of like those KT120 monoblocks. And so, yeah. And that's why I warn you guys, do not build these along with me, even though I've shown you the schematic, and it's I think the guy's name was DHT Rob, that's a pretty famous triode amp designer. This was kind of his, it's a kind of like I did with the Kegger schematics. It's a lot of their design, but then I've changed some things up to simplify it and just work with the tubes that I found available and the iron that I found available. He was using this giant toroidal transformer, and I like using EI core transformers and all of that stuff. So I'll link his website below. Go check out what he's got to say about this. He powered up both sides of the heaters. We're just doing one side, mainly because I didn't want to have to put a second filament transformer in, and I think it'll run the tubes cooler. Some people say that they don't last long if you do that. I don't know. There's so many different people that are like experts on these tubes that say the polar opposites of each other. Some people that are these self-proclaimed experts say you should never cathode bias these, and then the next guy says you should always cathode bias these. And I'm sure in the comments, I'm going to get, on the previous videos, I've got a lot of comments from people saying, yeah, you can't build them like that. This isn't going to work. And I don't know, it may not. I've never used a plate choke before. We're using the plate choke to really boost the output of this 9-pin driver tube we're using. And hopefully that's going to give it enough drive to drive this hard to drive, high capacitance tube. These things are known to be hard to drive, and that's kind of the trick to making them sound good. So, at the end of the day, this thing might make 8 watts instead of 20 watts plus that other people get out of them. But if it makes a nice sounding 8 to 10 watts, I'll be happy with that, because that's all I need. I don't need a 20, 25 watt single-ended amplifier. So we will find out when we put this thing on the audio analyzer suite. So Hopefully you're enjoying this content. If you are, please subscribe to the channel. Please like the video. Thanks to all you Patreon supporters. That really helps the channel. Also, thanks to you folks that make random donations. That's super nice too. And thanks to all you regular viewers. You're why I do this stuff. So, till the next video, have a nice day.